Hey everyone, welcome to today's Explainer. I'm so glad you're here because today we are pulling back the curtain on literally the most talked about tech of our generation. You know the drill. We've all been sold this magical dream, right? Sleek marketing, those flashy keynote presentations promising a totally frictionless future, and chatbots that make artificial intelligence seem like this weightless, infinite brain just floating around in the ether. But, well, today we're shattering that illusion. We're going to look at the very heavy, very physical reality of the invisible infrastructure that actually makes all of this tick. All right, let's dive into this contrast because it is absolutely fascinating. On one side, we've got the dream, this invisible, creative genius just hanging out at our fingertips 24/7. But on the flip side, the reality. And honestly, it is overwhelmingly industrial. The crucial thing to grasp here is that every single time you generate a quirky image for a presentation or ask a chatbot to summarize a giant PDF, you aren't just tapping into some mystical cloud. You are quite literally pulling a physical lever on a massive global resource machine. You might think, hey, I'm just asking for a quick pancake recipe. But halfway across the world, a massive industrial turbine is spinning up just to answer you. Tech giants kind of like to keep this physical footprint out of sight, but today we're bringing it right onto your screen. Section 1. The Energy Vampire. Powering the illusion. So this is where the sheer physical scale of AI starts to get crystal clear. We've got to bust the biggest myth in modern tech, the idea that AI is somehow a lightweight technology. Look, for years we've gotten used to the energy footprint of a standard internet search. It's tiny, right? Literally a fraction of a cent in electricity. But generating a single AI prompt, that requires a completely different level of computational muscle. Why? Well, because a regular search is basically just retrieval. It's like fetching a book that already exists in a giant library. AI, on the other hand, is performing inference. It's dynamically computing probabilities across billions of parameters to basically write a brand new book right there on the spot. It's a massive, intensive processing lift that completely dwarfs a traditional search. And hey, that's just the cost of inference, the daily usage. To really grasp the macro scale of this power drain, we have to look at the training phase. 5. That is the number of cars you would need to match the carbon emissions released by training just one single large language model. Think about that for a second. Think about the manufacturing, the gas burn, the decades of driving around for a single vehicle. Now multiply that entire lifetime carbon footprint by 5. That is the environmental output required just to get one of these AI models ready to answer its very first question. It means crunching petabytes of text data continuously, without stopping, for months on end. So where exactly is all this power going? It goes to data centers, but we really need to stop thinking about data centers as just, large buildings. They are entire cities built on servers. And the fundamental difference between standard cloud computing and AI computing, it comes down to the hardware. Traditional web hosting runs on CPUs that can basically sit idle until you click a link. But AI models, they need massive racks of highly specialized GPUs running all at once. They have to maintain this super complex predictive state in memory 24/7. They're always active, always processing, which demands a continuous, unrelenting flow of high-voltage power every single minute of every single day. Section 2. The water crisis. Keeping the cloud cool. Now, when you draw that much high-voltage electricity, you create an enormous byproduct, heat. And dealing with all that heat requires staggering amounts of our most precious natural resource. Let's walk through this heat cycle step by step so you can see how digital intelligence translates directly into physical evaporation. Step 1. The AI is running its calculations 24/7. Step 2. That relentless computational effort causes those dense GPU clusters to run incredibly hot. Like, if left alone, the hardware would literally melt itself down. No joke. So how do we fix that? Step 3. Evaporative cooling towers. Data centers pump fresh water through these massive towers to absorb the heat. And here's the kicker. This often has to be pristine, potable drinking water because the minerals in untreated water would just calcify and destroy the delicate plumbing systems. So yeah, to keep your AI experience running smoothly, millions of gallons of perfectly clean water are evaporated straight into the atmosphere every single day. And this brings us to a really severe real-world conflict. See, these data centers aren't always built in places with an abundance of resources. In desert regions, where local farmers are strictly rationing water just to keep their crops alive, nearby data centers are drawing millions of gallons of that exact same local water supply just to keep their servers from melting. It's a literal tug of war between the physical needs of local communities and the operational demands of our global tech infrastructure. Trading water for words. Honestly, it's a stark, almost poetic metaphor from our sources. But man, it perfectly captures the visceral reality of the AI water crisis. Every generated essay, every synthesized line of code comes at the cost of physical water drawn from our Earth. The asymmetry here is just wild to think about. Is a generated email worth a liter of fresh water? Because, like it or not, that's the reality of the transaction happening entirely behind the scenes. Section 3. Human and material costs. The fragile supply chain. So we've talked about the power and we've talked about the water. Now we're diving even deeper to look at the extracted earth and the labor that builds the physical brain of AI. Because this hardware definitely does not grow on trees. It actually creates a massive geographic bottleneck. First off, we have rare earth metals, like cobalt, which are intensively mined in the global south, carrying an immense environmental and labor toll. Then, those raw materials are turned into those highly specialized GPUs we talked about earlier. And the vast majority of these vital chips, they're produced by just one company, TSMC in Taiwan, which requires extreme precision engineering and creates a huge geopolitical choke point. It takes this incredibly resource-intensive, super fragile global supply chain just to build the machines that run the AI. It's basically a fierce geopolitical scramble disguised as digital innovation. And beyond the hardware, there's a totally hidden human element. That sleek, polite AI you interact with, it doesn't just naturally know how to behave. It requires a process called reinforcement learning from human feedback, or RLHF. To actually pull this off, there is a massive workforce, largely based in the global south, working manually to label data. They are the ones filtering out the toxic, violent, or biased text. It requires real people looking at the absolute worst parts of the internet, often for pennies, to teach the algorithm what to block so that the end product looks autonomous and polished. So yeah, the supposedly independent machine actually relies heavily on underpaid human labor.
Section 4. A call to responsibility. Weighing the costs.
Having uncovered all of this invisible infrastructure, we have to bring the narrative back to the choices we're facing right now. The sources outline a very specific proposed solution moving forward, and that is the demand for green AI. But, what does that actually mean? Primarily, it means energy transparency. Right now, tech giants guard their energy and water usage data like highly classified trade secrets. The push for green AI argues that we, as users, should have the right to know exactly how much energy and water it takes to generate a single digital output. Think about it. Just like we have nutritional labels on our food to understand what we're putting into our bodies, we need environmental labels on our AI usage so we can actually measure the true cost of our digital habits. Because ultimately, this is the grand conflict we're staring down. The efficiency gains of artificial intelligence, they are completely undeniable. AI is being used right now to optimize global logistics, analyze massive data sets to cure diseases, and unlock incredible creative potential. No one is debating that. But if the byproduct of that efficiency is the rapid depletion of our water tables and a massive surge in carbon emissions, we're forced to ask a really heavy question. Are we actually building a smarter, more sustainable future? Or are we simply accelerating the burn of our planet's resources? When you really look at the energy vampires, the localized water crises, and the fragile hidden supply chains required to make this magic happen, is the price too high? It's a question that challenges the very foundation of our daily tech consumption, and honestly, it's one we are all going to have to answer in the years to come. Thank you so much for joining me for this explainer. Keep questioning the systems around you, and I'll see you next time.